Okay, so now we're going to talk about drainage and wastewater, and we're going to just talk about how the two or three different types of systems come in and out of the home. So the same way I asked, where did water come from and where do you get your water from when you open the tap? Where is that water going to? And do you know where that water is going to? And do you know what happens to that water once we use it? So give that some thought while I'm speaking, because now we've got a lot of systems that we can use to save that water and to reuse that water and to make the most of it. And the thing that I want you to think about is, even in a large scale project, the amount of water that gets used and the amount of water that gets wasted, is there a way that you can help the client, or when you design something, is there a way that you can help to reuse that water in some way? So let's go through the basic plumbing systems. Let's go through, we've got our house here, and we've got 3 stories, and we have our cold water coming in, and it goes and it supplies a bath, and it goes up and it supplies another bathroom, and it goes up and it supplies another bathroom. And then what happens is we've got a geyser in the roof, and then that geyser comes down and it supplies hot water, and it supplies hot water, and it supplies hot water, which is basically what we've just previously discussed it, hot and cold water. So that's 2 systems, cold water in, hot water in, or hot water out. But now we've got drainage. So we've got our bath here, and I fill up the bath and I'm done with the bath, and now I need to drain the water. So I pull the plug, and what happens is this water goes out into a pipe and it goes down. Now we've got the same on all 3 floors, alright? So we've got the same on all 3 floors. So we've got a bath, bath, a bath. When I pull the plug on these, they all go down into a pipe and then they go out. But where do they go to? Well, in a house, we've got a sewer which goes down out through the house and connects to the municipal connection in the street. So in this house, the council has given us a connection, the municipality, and they've said, cool, you can connect onto this. And then what happens is, when you flush, it goes down via gravity, it always flows downhill, and it gets to the road, and then it goes to a treatment plant. There's lots of different treatment plants, and we clean hundreds of thousands of litres a day in Joburg. Actually, South Africa's got some of the cleanest water, and it's considered to be some of the purest and cleanest water provided by government institutes. Do you know the difference between grey water, black water, and wastewater? And what's coming out of this bath when I pull the plug is grey water. It is waste grey water. Then what I've got is, out of a shower, I've got grey water. Out of a sink and a dishwasher, I've got grey water. However, out of a toilet, I've got black water, because that contains sewage. So that is different type of wastewater. And because it's black water, it costs a lot more to clean, it costs a lot more to reuse. So often it is done, and it's done in various places, but it costs a lot more. But often we don't recycle the black water, we recycle the grey water, which is easier and cheaper to clean. And so what happens is you run your bath, you pull the plug, and then instead of it going out, you send it to a tank. So there's two different ways. One is it would go to the municipal sewer. Number two is it would go to a tank. And I'm going to be explaining tanks and recycling and conservancy tanks just now, but just keep those two in mind. How can we reuse that water? Then we've got a fourth system, and we would call it stormwater or rainwater. What happens is I've got a gutter over here, and on that gutter I've got a pipe, and then that collects my rainwater and goes into a pipe, and as it rains it's discharging water. Now often that water just gets wasted, and it just goes down the driveway, or it goes down into the garden, and that's it. So we can also take this water here and reuse it, take it and put it into a tank. And so those are the different types of systems. So we've got hot water, cold water, drainage and stormwater. Well, drainage in wastewater and stormwater. So I just want to do a bit of a close-up on what it looks like and what a trap is. I want to explain to you now what a trap is. So what we have, we've got a sewer pipe coming in from the municipality. It comes up and it goes to our house. Over here we've got our bath. And then we've got, sorry, I'll draw this over here. When I pull the plug from this bath, the water, okay, so now I just want to explain to you a close-up of a fitting and how the waste works and how that fitting is actually connected to the waste system. Now, a waste pipe, as you can imagine, a waste pipe needs to be connected in such a way that we do not separate, that we do not connect the two systems together. So you don't want to be drinking wastewater, and you want, that's why those two systems are separate. So we want to separate the drinking water, the potable water, from the wastewater. And what happens is our cold water comes in, like I've drawn there, and our wastewater goes out. But a waste pipe, a waste system, sometimes smells and sometimes contaminated with sewage. So what we have here is we've got certain types of traps, we've got certain types of pipe work. Usually waste pipes are made out of PVC, plastic now. Before they used to be made out of cast iron and lead and steel. Now they're made out of plastic or HDPE, high density polyethylene, and they need to be constructed in such a way that they are vented so that the system can breathe and pull, and that they are and that they don't smell. So what we have here, we've got our municipal connection. So that goes to the council, and that would be our pipe that runs down our building or our house. And so the sewage comes down when you flush or whatever, and it gets connected from the bath or from the shower or whatever. And here we have a bath. So I run my bath and I want to drain it. So I pull the plug pull the plug on my bath, and what we put in there is a trap. We put a trap so that when I pull the plug, this water goes down, but when this is standing empty, this trap stays filled with water. And then I do not smell the pipe work. The pipe work also needs to be vented. So if you see on most buildings, if I have a building, there's a vent that goes up out of the building, and that is to pull the air through and down and out. And so your ventilation, when you pull the plug, if it's not vented correctly, you will have, your toilets will bubble up, or they won't drain fast enough, or they'll gurgle as they're draining. That shows that you have insufficient air in the system. It's almost like holding, you know, when you put a card on a glass and you do that magic trick and you put the glass upside down and then you let go. The vacuum holds the card until there's enough air to release it. So you need a lot of air in the system, you need ventilation, and that's part of drainage. So I just want to talk to you quickly about what the best way of running or designing your drainage system is. And you always got to be cognizant of obstructions. You got to be cognizant of long runs for drainage. You've got to be cognizant of too many bends or elbows, because they cause blockages. So when you're designing a drainage system, you always want to try and keep the pipes as straight as possible on the side of the house, on the side of the building, or in the basement, a straight long run. Limit your amount of elbows and bends because they cause blockages and obstructions. You want to be, when you're running a horizontal pipe, you want to limit the length as much as possible. Your vertical pipes, they carry gravity, and the water works on gravity, so it's not forcing itself to make its way out of the pipe. So your horizontal runs are going to be your most crucial, and keep an eye on those. And I also want to talk about ventilation. You need a lot of ventilation. I've explained it, but the regulations are that a pipe or a system must vent out through a roof. Where it can't vent out through a roof, it must vent away minimum of 2 meters above any window, because you smell the system. So you want to have an unobstructed open vent. You can get caps that stop birds from falling in and all these things, and grids, but it must be unobstructed, and it must be open vented where you can. In ducts, we have special valves, one-way vent valves, where if you don't have space to punch a vent out through the roof, you can use a special valve. But ventilation, there are regulations that you need to abide by for ventilation and for drainage. But yeah, keep in mind, you want to limit the pipe runs, keep your waste as short as possible, as with a good fall, and as least amount of bends and elbows. Also, another thing you need to consider, we need inspection eyes to inspect the pipe, and we need rodding eyes to clean the pipe. So in certain places, every 25 meters, you need a inspection eye to be able to inspect the pipe. Every change of direction, if you change the direction of the pipe, if you're running this way and you need to turn right to get across a basement or across a courtyard or something, you need to put an inspection eye. So you'll see in your notes and in your documentation, you need to look at the SAN standard, and you need to abide by that standard for your pipework designs, for your wastewater designs. So now I want to talk to you about the fall in a system. The fall is when we talk about fall, we talk about the gradient of the way we run a pipe. Now, in a water supply, you don't need to be considered, you don't need to think about the fall per se. You do need to think about overcoming pressure, but you're not governed by a fall. When you talk about waste, you need a certain type of fall so that the water can make its way down adequately and not leave solids behind in a pipe. If you have too long a horizontal run or too long of a pipe with an inadequate fall, the water will go faster than the solids and it'll cake up your pipe and it'll leave your pipe becoming blocked and full in no time. So what we do, your minimum fall required will be on any system. We're talking about sewerage and wastewater, will be 1 in 40, which is calculation which is for every 40 meters of pipe that I run, I drop 1. So my gradient, my fall will be every 40 meters I drop 1 meter. So if I have a 40 meter driveway, at the end of it my pipe will be 1 meter lower. If it, in the same in my house. So if I'm running a bathroom, or let's say that the first floor here, with the first floor, and this is my main pipe, and I want to go and pick up a shower, I want to pick up a bath and a basin. This pipe has to drop 1 in 40, and as it drops, I have to make sure that my gradient falls enough for the water to go down. So when you're calculating distances and when you're calculating your designs, you need to consider that where's the plumbing going to run, how's the plumbing going to run, because the plumb is going to be governed by your designs. Also, where do you place your ducts, where do you position your ducts, so to make it easy to maintain, to make it cheaper, because we don't want to use a lot of material if we don't have to. If ducts are placed in certain ways, they will bring the cost of the project down, because we'll be using less pipe. Maybe you can put bathrooms back to back so that they use the same duct going down in the same stack. So be cognizant of those things that will save the client money, that will save the plumber or the person installing. That'll make their job easier, and it'll make it easy, and it'll make the system work well. And always remember, with drainage, you need a lot of ventilation. Alright, so let's just talk about a conservancy tank or a septic tank and how those work. So basically, a septic tank, like I showed you in that model, the cold and the hot water come into the house, the rainwater comes down from the gutters, and that I'll show you in the next module of rainwater harvesting, and the wastewater goes out to the municipal sewer. But we do have an option where we can take that wastewater and put it into a tank. So basically we've got our building, and normally septic tanks and conservancy tanks are buried underground. You don't want these tanks above ground. They've got wastewater and sewerage, and so you don't want these above ground. You want them buried out of sight. So we've got our house, we've got our bathrooms in that house, and out of that house comes our main sewer. What would happen is we bury a tank, we bury a conservancy tank or a septic tank, and this sewer comes in here. Then what we can do is we have filtration systems. We have filtration systems and pumps that would clean the water and repump it back into the house, or pump it back for irrigation, or reuse that water in some way. So what would happen is we would flush our toilets, we would use the water in the sink or the shower, and it would come down the sewer, and it would come into our tank. Inside the tank we have a system that purifies we have a pump, and that pump pumps the water out into a filtration plant, which cleans the water, and then that water has that filtration plant has another pump that will pump it either to the irrigation or back to the house, depending on the quality of water, and then that can be reused. And so what's happening is you're creating a cycle that you continually drawing off water, reusing the water, drawing off, reusing the water. Now, obviously there's a cost to install that system, and because of the high cost of the systems, often people don't go for it because the payback period is too long. But as water gets more and more expensive, we're going to need to be looking into these options. As water becomes more and more scarce, we need to, it's not about money anymore, it's about resources becoming depleted.
This is a typical septic system here. This pipe comes out of your house into your septic tank at your main sewer line. Everything that goes down your drains and your toilets comes out of that. In the septic tank, it is treated by bacteria, we'll explain that in a few minutes, and a liquid sewage called effluent exits the tank and goes out into an effluent disposal system, which in this case is a drain field. Okay? The drain field consists of perforated pipe, trenches that have stone in it, and soil on top of those trenches, and what's called a distribution box. So the distribution box evenly distributes the effluent to the various legs of the drain field. I personally think the heart of a septic system is the septic tank. That's where all the magic happens, so to speak. And it's pretty interesting because it all happens naturally. The sewage from your house enters the tank and goes through what's called an inlet baffle. And then the liquid that goes to your drain field exits through an outlet baffle. The outlet baffle, as you can see, keeps scum from getting into that outlet. And also, as the sludge in the bottom of the tank comes up or rises in the tank, that sludge could get out into your drain field and clog it up. And then you're really in trouble because you're going to be spending big bucks to replace your drain field. What happens is there's bacteria in the tank that breaks the sewage down to a sludge and a liquid sewage. The scum is actually everything that you put into your drain lines, flush down your toilets that you shouldn't put there. It's grease and oils from cooking. It can be dental floss, baby wipes, feminine products. It's just stuff that the bacteria is not going to break down. Those things getting into your drain field, yeah, they're bad for it too.
So yeah, that is a septic tank and how we can reuse wastewater.